Hey everyone, and welcome to our final topic. We are going to be looking at one more sorting algorithm, discussing how it works, showing its implementation, and talking about its analysis in relation to other sorting algorithms. So this sorting algorithm is known as QuickSort, and we're going to start by just an overview, a really basic overview. We're going to build our mental model for what QuickSort is actually doing. The easiest way to do this is going to be with an analogy that has nothing to do with code and numbers. So let's imagine that we're sorting out our closet. We want to make sure that our favorite items are really easy to access. Pretty straightforward. So what are we going to do? Here's how the algorithm works. Step one, we pick an item. We're just going to grab an item and hold it. And that's going to be sort of like our anchor point, our pivot. We're going to sort all of the clothes in our closet into two piles. Ones that we like less than our anchor item, the one that we're holding, and ones that we like as much or more than that item. After we've done that, we'll have two piles and our anchor item in front of us. For each of those piles we've created, perform those steps again. And then for each of those piles, perform those steps again. And keep doing this all the way until we hit a pile that cannot be divided any further. For an example, an empty pile or a pile that only has one clothing item in it. Similar to our merge sort base case where we said an array of size 1 is already sorted. Same idea here. Then we can recombine everything. We can rehang our clothes starting with our least like clothes first so that they're in position 0 through J, then our anchor or our pivot shirt that we use to separate around, and then our more like clothes, and repeat all the way back up. This is broken into two steps, partitioning and recursion. So let's take a quick look at this from a visual standpoint. Here's my closet, and I've decided it's time for me to organize it. So I'm going to just grab the very first shirt that I can reach, my super cool dinosaur shirt. And now I'm going to look at each sequential shirt and ask myself, do I like it more or less than my cool dinosaur shirt? Well, I've decided that I like my pink flower shirt less, so I'm going to put it in my likes less pile. And then I move on to the next shirt. And this will just continue for every single shirt in my closet until I now have two piles, both centered around my original pivot shirt of my dinosaur. Then we go on to steps 3 and 4, which was going into each of these piles and repeating steps 1 and 2. So let's go into that likes less pile next. And let's look at this exact same problem space. Let's go ahead and grab an anchoring shirt. This time we'll grab the pink flower shirt. That becomes our anchor. And then we can look at the other shirts in this pile and ask ourselves, do we like it more or less than our anchoring shirt? Once we've made those decisions, we've now separated it into further piles. Now, when I look at my like less pile, I see that there's only one shirt in there. That's a base case. And when I look at my likes more pile, I also see one shirt, which is a base case. So now I can tell that I am totally sorted on this level. I can't go any deeper. What do we do now? We start to recombine. We rehang all of our clothes. Likes less, anchoring shirt, likes more. So we've just put them in exactly that way. When we are reinserting into our closet like this, we're only ever doing it when we hit that base case. So we'll never have a situation where it's like, how many shirts, if you have multiple shirts in likes less, how do you know which one goes first? Like, that's not going to happen. We sorted all the way down until we reached a situation where we only had a single shirt in a pile. We had a likes less shirt, we had our pivot shirt, and our likes more shirt, and now they can all be entered in. Once we've completely finished everything on that side, we can now go and insert the anchor shirt from the previous stage. So in this case, that was our dinosaur shirt, because I've now finished processing everything I liked less than my dinosaur. So now my dinosaur shirt can go in, and I can go ahead and now process my likes more side based on that dinosaur shirt. I can go ahead and just grab a shirt. This is going to be my pivot shirt, and I decide I like my red shirt way more than my denim blue shirt. So I actually end up in a different base case scenario here, but still similar. Likes less is just empty. Then we have this one, and then we have the base case over here of still one shirt. We figured out my favorite shirt as well at this point. We can see it's this red shirt. So now I can go ahead and add these in. My likes less is empty, so that doesn't actually go anywhere. My anchoring shirt from this level can now take up this space, and my likes more can take up this space. And now I have no piles left and I'm all done. I have sorted my closet from least liked over here to most liked over here. Now, of course, we probably wanted most liked shirts to be up at the front of our closet, But you have to imagine that I wanted to align this with numbers, so like chronologically ascending. This just seemed to make the most sense from least to most. So hopefully that doesn't throw you too much, because it did when I was trying to even just create this presentation. So what are the big facts for this quicksort process? Well, the first one is one I've already mentioned a bunch. If a pile is empty or only has one element in it, we can't divide it any further. We have to consider it sorted. We also always processed our shirts or our clothing items in the same order. We divided around a given shirt, we processed our least favorite pile and recursed down that side as much as we needed, and then we moved the anchor shirt to our closet, and then we processed our more favorite pile and recursed as needed, and then moved it all back to the closet. This is going to become a really common theme in how we do our processing. And if you have a pretty good understanding of how merge sort works and the divide and conquer that we do there, QuickSort is a very similar algorithm in that we are doing a divide and conquer. And that's how the magic of QuickSort really works. So this is really meant just to be a very quick overview, visually understanding how QuickSort works, what we're going to do with these pivots. And in the coming videos, we're going to see how we actually keep track of all this information. A big hint is the runtime stack and recursion is going to be incredibly helpful for all of this managing of positions and piles and such. And we're going to actually implement the code and do a little bit of analysis on it as well. Thanks everybody, and I'll see you in our next video all about partitions and pivots.